Scientists are thrilled by recent groundbreaking discoveries from the James Webb Space Telescope. The telescope has observed an extraordinarily unusual phenomenon that appears to defy the physical laws as we currently understand them. This finding has prompted some researchers to propose that the universe might function like a living system, capable of evolving over time.
I don't believe in any religion I've seen. So, in that sense, I'm an atheist. However, I would say that there is something going on which might resonate with a religious perspective.
When we think of the universe, we often picture a vast expanse of matter governed by physical laws that control everything from the motion of stars and galaxies to the behavior of subatomic particles. For centuries, scientists believed that by understanding these laws, we could fully comprehend how the universe works. Indeed, the laws of physics have done an excellent job explaining planetary motion, stellar dynamics, and particle interactions. However, when we trace the universe back to its origins, these familiar laws begin to break down. The physics that governs our present-day universe struggles to explain the conditions of the early cosmos. Recent discoveries from the James Webb Space Telescope, JWST, are beginning to uncover this hidden complexity. As the telescope peers deeper into the past, it reveals surprising clues that challenge our current models. For example, scientists expected to find small, developing galaxies in the early universe, yet JWST has identified massive galaxies existing just a few 100 million years after the Big Bang. Even more perplexing is the discovery of a supermassive black hole from 1.5 billion years after the Big Bang, consuming matter at 40 times its theoretical limit, something current cosmic models cannot explain. These findings suggest that the early universe, only a few 100 million years post-Big Bang, was fundamentally different from the one we know today. Some scientists now speculate that the laws of physics may have functioned differently back then, allowing phenomena unseen in the modern universe. But it's not just the discovery of ancient galaxies and massive black holes that's causing a stir. The JWST has also detected signs of non-uniform space expansion, hinting that we may be missing a critical aspect of the universe's nature. These revelations are prompting scientists to reconsider long-held beliefs. In fact, recent findings suggest that the universe may be evolving like a living system, sparking intense debate among astronomers. Some, like Lee Smolin, a physics professor at Penn State Center for Gravitational Physics and Geometry, are exploring the provocative idea that the universe could behave more like a living, evolving entity. This notion, while bold, has roots in both science and philosophy, with recent JWST observations adding renewed weight to the idea of a sentient or self-aware cosmos. This idea proposes that the universe evolves and changes much like a living organism. Over the years, various experiments have hinted that the universe might exhibit behaviors resembling those of living systems. One notable study from 2020, led by astrophysicist Franco Vazza and neuroscientist Alberto Felletti, explored striking similarities between the cosmic web, the large-scale structure of the universe, and the human brain. By comparing the network of neurons in the brain to the network of galaxies in the observable universe, they identified surprising parallels. For example, while the human brain contains around 86 billion neurons, the observable universe holds approximately 100 billion galaxies, both connected by vast networks of filaments and nodes. Additionally, both systems share a comparable distribution of active and inactive components. About 25 to 30% of each system consists of active elements, neurons in the brain and galaxies in the universe, while the rest comprises inactive material, like synaptic connections and dark matter. This comparison has led some to speculate that the universe might function like a colossal brain, potentially processing information in a way similar to neural networks. Though highly theoretical, this idea opens the door to the possibility that the universe could behave as a living, evolving system. In a separate line of inquiry, theoretical physicist Gautam Sai-Chandran of Princeton University, along with Daniel Danielson and Robert Wald from the University of Chicago, conducted a quantum thought experiment involving black holes. Their findings suggest that black holes exhibit behaviors reminiscent of a living entity, further fueling the intriguing idea that the universe might be more than a passive collection of matter and energy. It could be a system that observes, adapts, and evolves. The team began by imagining a thought experiment involving two observers, Alice, conducting the classic double-slit experiment in a lab orbiting a black hole, and Bob, stationed just inside the black hole's event horizon. In the double-slit experiment, when a particle such as an electron or photon is fired at a barrier with two slits, an interference pattern, typical of wave behavior, emerges if the particle's path is not observed. However, if an observer measures which slit the particle passes through, the interference pattern disappears, and the particle behaves like a solid object, going through one slit or the other. In this scenario, the twist is Bob's unique position inside the black hole's event horizon, the boundary beyond which nothing, not even light, can escape. Despite being trapped inside, Bob can still observe which slit Alice's particle goes through. If Bob makes this observation, the particle's quantum state collapses, and Alice notices the interference pattern disappear, indicating that someone measured the particle. Here's the paradox. By the laws of physics, no information from within the black hole should influence the outside world. Yet Alice can infer Bob's observation from the collapse of the wave function, suggesting an impossible form of communication across the event horizon. The team proposed a solution to this paradox. The black hole itself is responsible for collapsing the quantum state, regardless of Bob's actions. According to theoretical physicist Gautam Saichandran, the black hole's event horizon inherently knows the particle's path. Therefore, Alice's experiment is disrupted not by Bob, but by the black hole's gravitational influence, resolving the paradox. This led scientists to a broader realization: horizons of any kind, not just black hole event horizons, can act as observers that cause quantum superpositions to collapse. Since gravity cannot be fully shielded, any boundary where information flows in only one direction can exert this effect. This includes the cosmic horizon, the edge of the observable universe, which behaves similarly to a black hole's event horizon by preventing information from traveling back. In this sense, the universe itself appears to be observing everything, ensuring particles behave predictably rather than remaining in indefinite superpositions. This idea echoes the work of renowned theoretical physicist John Wheeler, who in the 1970s visualized the universe as a participatory system. Wheeler often drew a large U symbol, with one tip representing the uncertain, quantum beginnings of the universe, where all possibilities existed simultaneously. His vision implied that the universe actively shapes its reality through observation, a concept now finding new relevance in these cosmic horizon studies. The right tip of John Wheeler's iconic U, sometimes depicted with an eye, symbolized an observer looking back in time, effectively bringing the left side, the universe's early quantum possibilities, into existence. Wheeler referred to this concept as the participatory universe, where the cosmos evolves and cools as it forms structures, eventually creating observers like humans and measuring devices. By observing the early universe, these participants retroactively make it real. Recent quantum experiments near black holes have strengthened this concept. As researcher Dan Danielson explains, the idea that black holes and even the universe's cosmic horizon are constantly observing everything aligns closely with Wheeler's participatory model. Whether we like it or not, the universe seems to be in perpetual observation, suggesting it may be alive or conscious in some way. Based on these findings, scientists are now proposing that the universe evolves like a living being, adapting, learning, and improving over time. This implies that the physical laws governing the universe shortly after the Big Bang may have been different from those we observe today. William Cunningham, a physicist and software lead at the quantum computing startup Agnostic, supports this idea, suggesting that the laws of physics are not fixed but evolve as the universe learns how to function more efficiently. The researchers have introduced the concept of an autodidactic universe, a self-learning cosmos, similar to a machine learning algorithm where feedback from one stage influences the next. The universe could be evolving toward greater stability, much like a moth developing better camouflage over generations. According to the mathematical framework they've developed, each iteration makes the universe more stable than before. Supporting this theory, Proto Dahl from the University of Groningen's Kaptein Astronomical Institute points out that today's universe is far more hospitable to life than it was when early microbes first emerged on Earth. In fact, the universe continues to improve, forming stars more efficiently now than it did when galaxies were young. This suggests that the physical laws of star formation have evolved over time, making the universe increasingly conducive to life. However, this raises a profound question: how does the universe know how to evolve? Could the universe itself be alive? Renowned physicist Dr. Roger Penrose has proposed a groundbreaking idea: consciousness might play a crucial role in shaping the universe. Penrose's theory challenges the traditional view that the universe operates purely on impersonal physical laws, suggesting instead that consciousness, the inner experience of awareness, may influence cosmic evolution. Consciousness, the awareness of oneself and the surrounding world, is what makes us sentient. While physical laws explain how particles interact and energy flows, they say nothing about consciousness. Imagine if the universe itself possessed a form of consciousness, a cosmic mind guiding its evolution and influencing its trajectory. In this view, the universe wouldn't just be a collection of inert matter obeying mechanical laws, but a dynamic, living system that learns and adapts over time. This theory offers a potential explanation for the mysterious early galaxies and black holes recently observed by the James Webb Space Telescope, which defy our current models. If the universe is conscious, it may be constantly evolving, growing more complex with each moment. This concept invites us to explore deeper layers of reality beyond what we can perceive or measure, redefining the relationship between mind, matter, consciousness, and the cosmos. Thanks for watching.